To do is we're going to talk about networks and what are the factors revolving around those networks. Okay. So I'll start with a very basic question. What is a network? And what you see here is a description from a very famous book. What? Guess I'll have to mute all of you. All right. So coming back to the main topic, and raise your hands if you know the answer, right? Like I said, don't unmute unnecessarily. That's going to ruin the experience for everyone else as well. So yeah, coming back to the question, what is a network? Now the description that you see here on my screen is from a very famous book, you know, written by two authors, Kuros and Ross. But this book is really old, and we are now living in 2025, where we have a lot of new technologies. Okay. So according to you, what is a network? Is this description good, or do we need to include something else as well? Yeah. So that's my main question. Yeah, raise your hands if you know the answer, and I'll unmute you. Yeah.
Sir, I think the
Mm-hmm.
description is right that we need those are devices that are connected with each other and communicate, like
Mm-hmm.
computer, laptops, printers, switches, routers,
Right.
servers.
Yeah, so when you talk about those devices, we first have to categorize them accordingly, right? So if you look at the description, it says that it's a set of devices connected by communication links, and they're known as nodes, right? So this is what is the description of a node. A node can be computer, printer, or any other device capable of sending and receiving data. All right. So the first thing that we have to do is we have to divide all these devices that you just mentioned, Avneet, into two categories. The first one is going to be the nodes, and those are the devices that want to talk to each other, right? And then we'll put our routers, switches in another category, because those are the devices that are going to help nodes communicate with each other, right? And then we have links. So what are links? Links are different media which will help our nodes talk to each other. Like it could be a wireless communication, it could be wired communication, right? If it is wireless, what categories would it fall under? If it is wired, then what kind of cabling mechanism are we using? Okay, so what I'm going to do is I'm going to take this definition and break it into smaller parts. So let's start with the first one. So we have our nodes. Okay, so node can be a computer, can be a printer, but now if we talk about the new devices, we've got smartphones, we've got tablets, and this is 2025. We've got, I guess, more than billion IoT devices. Even those can be considered as nodes. So if you have, calling functionality in your cars, they can also be considered as nodes, right? So that is what a node is. Now, how are they going to communicate with each other? They will communicate with each other through the help of networking devices. So what are these networking devices? They can be anything. They can be routers, they can be switches, they can be WLCs, right? They can be access points, anything. And then the last component of this definition or this description is a link. So what is a link? Link can be wired or it can be wireless. All right. Now, when it comes to wireless, can be a lot of wireless methods like Bluetooth, Wi-Fi, NFC, infrared, they're all a part of a project which we will be studying very soon in our course. It's called the 802 project or the 802 project. And then if you talk about wire, then you can have a copper cable, right? Or an optical fiber cable. So now that we're talking about these two forms of cables, copper and optical, uh, which one of them is Ethernet? Can anyone tell me? Although we will be covering this in our course, so don't worry. Will you consider copper or Ethernet a part of Ethernet? I mean, copper or optical fiber a part of Ethernet? That's my question. Yeah.
Optical fiber.
Okay. So some of you have written copper, some of you have written optical fiber. Well, the answer is both. Both of them are going to be a part of the Ethernet standard. Okay. So Ethernet standard, it is 802.3. And then so you have cabling standards inside Ethernet for copper and cabling standards for optical fiber. Got it? So we are going to talk about this in our course. Usually what happens is a lot of people get confused whenever Ethernet is mentioned. Automatically what comes to their mind is copper. That is not correct. It's optical fiber as well. And very soon, well, in our course, we are also going to talk about some cables that can provide power to smaller devices like access points or IP cameras. They also come under the Ethernet standard, and that specific standard which I'm referring to is known as Power over Ethernet. So for those of you who know about all of these standards, that is great because we will be covering this. And for those of you who have no idea about what I'm talking about right now, that's okay, don't worry. We have lots to cover in this course. Okay, so that is what a network is. And in this course, what you're going to do, you are going to work with all sorts of devices, but you need to understand why you are working with them, right? Because what usually happens in a lot of courses, you get to understand what a network is, and then you straight away start working with different devices. It doesn't make any sense, right? Because if you're a network engineer, or if you're about to become one, and you start working for an organization, uh, you need to understand the concept of topology, right? And why you are building that topology. So what topology is, I'll talk about that, but let me discuss the main factors that we have to choose whenever we select a network or whenever we create a network. So those three factors are performance, reliability, and security. In an ideal world scenario, we need to make sure that performance, reliability, and security are at the highest level, which means that performance should be 100%, reliability should be 100%, and security should be 100%. But that is just not possible. And it totally depends on the use case for which you're creating or configuring a network. Okay. So what is performance? High speed, high bandwidth, right? Minimum delay, maximum throughput. Are you getting my point, everyone? So the internet speed should be really high. The network speed should be really high for the configuration that you have created. You should have the best devices, state-of-the-art devices like the newest or the latest series of the routers, latest series of the switches, latest series of all the other networking devices that you're going to use, right? That is what performance means. When you talk about reliability, uh, well, you can have the best devices in your network, but what if those devices fail? What's going to happen next? So that is taken care of by a factor known as, or a component known as reliability. So what reliability states is that if you have one router, have a backup, have another one. If you have one switch, keep another one just in case if the original switch or the original router stops working. Is everyone getting my point? So that is what reliability is. Now, even in the worst case scenario, when your devices stop functioning, you should have something known as a failover mechanism. Let me write it for all of you. So the term that I'm going to use is failover. All right. So what failover does, if your primary device stops working, immediately secondary will take over so that the customer or the client does not feel any change and is able to use your resources as they were doing before. That is what failover is. And then the final component, which is security, you need to make sure that you are applying these principles, CIA principles. So, can anyone tell me what CIA is in security? No? Okay, I'll explain. Confidentiality, integrity, and availability. Okay. So, what is security? Security means that you have to comply with or you have to adhere to these principles: CIA, confidentiality, integrity, and availability. Now, let me explain each term, one by one. So, what is meant by confidentiality? People who are supposed to use, or the customers who are supposed to use your resources, only they should have the access. Anyone else who is not authenticated or who is not a part of that specific list of customers should not be able to access your resources, should not be able to access your data. If that happens, then it is a loss of confidentiality. Got it? So for example, if all of us are in this session and you have paid for, this course, what if randomly, someone else joins this session and is able to access all the materials of this course, is able to attend all the live sessions without even paying, right? That is a breach of confidentiality. Got my point? So since all of you are, actual customers, only you should have access to these resources. That's what confidentiality is. Integrity. Now, what integrity means is that information can only be changed by authenticated or authorized people. So, for example, me, right? If I'm teaching you this course, if I tell you that something is wrong, because I know what to do, that's why I can change that material. Now, what if someone changes it on my behalf? Someone who is not even authorized to. That is integrity. That is loss of integrity. Are you getting my point? For example, let me give you another. Let me talk about another scenario. You have a bank account, right? You are the only. You have the credentials. You have a username. You have a password. what if, someone takes the money out of your account? Now, when you go to the bank says that you were the person responsible for that transaction, but actually you weren't. Somebody just randomly took the money out of your account. What is that? That is loss of integrity. And then you find out that other people who have an account with that specific bank have also reported the same. What does that tell you? It tells you that the bank, the bank's security is not that good. They don't have any integrity mechanisms. Integrity mechanisms, as in anyone, right, who is not even authorized to make those changes or authorized to make those transactions can easily do that without any confirmation from you, the actual customer. That is what integrity is. Okay. That is what loss of integrity is actually. And the final one is availability. So availability here is mentioned twice within security, all right, and within reliability. Now, when we talk about availability in terms of security, it means that it should always be accessible by us, even if an attacker tries to bring that service down. For example, let's take a scenario where, I'm an attacker and all of you are clients of networkings. So you have an exam scheduled for CCNA soon. So what you're doing is you are using videos from your portal to study for the exam, right? Now, because I am an attacker, what I'm going to do is I'm going to bring the server down by sending a lot of requests or by carrying out an attack like denial of service, right? So if that happens and you are unable to access the resources or the videos present on your networking's portal, that is called loss of availability security wise. Okay, because I purposefully try to make sure that you're not able to access those resources. But when we talk about availability within reliability, it means that the resources are not available because of a problem with the device. That could be a performance related issue, or that could be due to wear and tear of that specific device. Not that an attacker tried to purposefully, you know, bring down the availability of those resources. Make sense, everyone? Performance, reliability, and security. So these are the three factors that all of you need to understand. And we are going to use these three factors in every topic that we'll go through in our course. For example, if I talk about spanning tree, I'll ask you at that point, hey, which factor should we, adhere to or comply with the most? Got it? So yeah, questions. Go ahead. Any questions related to this? No? Okay. So let me ask all of you a question now. Okay. Let me give you two examples, and you have to decide in which order we should apply these principles. Okay. So let's say you are tasked to create a network or configure a network for a hotel. Okay. So now you have to comply with these three factors, but in which order? Okay. So which one is going to be the highest and which one is going to be the lowest? So write your answers in the chat box in the descending order, starting from the factor that you need to comply with the most and the factor that you need to comply with the least. Let's see. So yeah, for those of you who did not listen to my question, we are going to create a network for a hotel. Which factors among all these three, performance, reliability, and security, we should focus on the most? Okay, so Sish says Security, reliability, security first, then reliability, and then performance. Okay. What about others? Reliability, security, performance. Nice. Okay. Yeah, I'm just waiting for all of your answers, and then we'll have a discussion. Okay, so let's discuss the answer. So most of you have given extremely high preference to security, right? Uh, why? Can any one of you unmute yourselves and tell me, like, why would we need to have security at the highest level for a network inside a hotel?
So may I, Ashish here.
Yeah, Ashish.
Uh, so security we are looking out because of police related to terrorist attacks also. It can hack our network and you misuse it.
Hmm.
Okay. Uh, so that's the reason the security is more reliable. And because we are using Wi-Fi in past, I was staying in for example, in past I was staying in Bangalore.
Hmm.
Okay. And in nearby our guest house, there was a five-star hotel,
Okay,
and I was using their Wi-Fi to access internet.
okay.
So that is very easy to hack uh, and misuse for any unsocial activity.
Right. I mean, that is true, but
Yeah,
that is true,
and
but security is essential for, everything. But
yeah,
when you go to a hotel, right, you don't go there to just access their internet and make sure that, you're able to work on something really crucial. You go to a hotel in most of the cases for leisure, or even if it's for business, uh, you won't be you won't be using their resources all the time because it's a hotel. Number one, that's my point number one. And not all of the people who are going to stay at a hotel are extremely tech savvy. So all they need is access to the internet, right? And when you make sure that the security is at its highest level, you know what's going to happen, everyone? It is going to affect performance. So what I've actually written here is security is inversely proportional to performance, because when you enhance the security to its highest level, what's going to happen is that a lot of checks are going to be performed. You will have to perform multi-factor authentication. For those of you who stay at hotels, regularly, do you have to go through multi-factor authentication? No, right? In order to access a hotel's internet? Not really. All you need to have, right? All you need to have is access to the internet. That is it. If you are going to work on something, let's say if you have something office related, then you have to connect via VPN, right? Because you cannot trust a hotel's network. You cannot, let's say you go to a cafe and you start working from there. Um, Obviously your company's VPN is going to be on. Obviously your company's, other security solutions would be turned on, and they will be working in the background to make sure that you are not attacked. So when it comes to a hotel, security is not something that we need to focus on the most, because if you focus on security, you need to have state-of-the-art devices. You need to have the best firewalls. You need to have, you need to have all the configurations applied in your routers and your switches. For example, if we talk about routers, you will need to have access control lists applied. Why would I do that for, a hotel's network? I'm not saying that, your answers are wrong, guys, but if we look at it very carefully, we don't actually need to have security at its highest level in a hotel network. What we need to focus on the most is performance. Performance and then reliability and then security. Now, with that being said, I don't mean that we don't need security at all. We need security, but the way we would tune this is performance followed by reliability followed by security. All right. So that's how you would focus on these factors for a hotel network. Okay. So yeah, this was just the first exercise. Now let me give you another one. So what if you have to do this for a military base? Okay. Sorry about my handwriting. Well, what I've written here is military. So Aniket, no, it's not always the same. It can differ based on the demands from your prospective client. Okay. So this was just an example where you would
Okay,
have
okay.
performance at its highest level, then followed by reliability, followed by security. Yeah, so for the next one is military. So you're designing a network for a military base. What would you need? In which order should you, apply these factors? Okay, so let's. Okay, so let's see how it would work. The first factor would be security, and it needs to be applied in its highest form. For example, make sure that you have all the firewalls, you have all the intrusion prevention systems in place, you have the best firewall rules so that nobody can intercept what's going on, so that nobody can make changes to the data that flows through. It is always available to the users who are using this network, right? So the first factor would be security, followed by reliability. It should always be available because let's say in in an emergency situation, what if that network goes down? We wouldn't want that, right? We want to make sure that the specific network is always available to us. If one specific device stops working, we should have a failover mechanism, that should help us out in this scenario right away. And then we are not neglecting performance. We are just placing it at the end because we are okay if the speed is a little less, right? We're okay with, the fact that we are not using the fastest devices. Okay, so this is a decision that you have to make, that you need to have security at the highest, then followed by reliability and then performance. So that is how it's going to work. Make sense, everyone? So did you now understand the the relevance of these factors and how they govern, you know, each and every level of when you configure your network, right? So that's the network criteria: performance, reliability, and security. And then these three terms are not just applicable to networks; they are applicable to everything. right? They're applicable to everything in computer science. Let's say you're a cloud engineer. Well, you need to make sure that you're using the best cloud vendor. You can easily spin up, virtual machines on your cloud without waiting. They are reliable, so if one virtual machine goes down, you can easily access, the other one in its place, and then you're secure. Nobody can steal your data, nobody can modify your data. So that's how it is. Okay. So these three criteria, these three factors are applicable everywhere in computer science and even in real world, right? Let's say you get a really nice car, but what if it's not reliable? What if it's not secure? You park it somewhere, and then anybody can use a device, to remotely, let's say, hijack into your car. So these three factors apply everywhere. Okay, so on to the next slide. Now, what we're going to talk about before we discuss the structures of a network, we will now talk about standardization. Okay, so before I talk about unicast, multicast, broadcast, what is point-to-point, what is multi-point, I will circle back to this slide set. For now, what I'm going to do is I will open up another document that's called network models. This is something that we will be discussing in detail tomorrow, but at least let's start. Let's try to understand what this is all about. Okay. So we've already talked about what networks are. Okay, we took a very generic description and we try to break it down and we try to understand, what the components of a network are, what's a node, what's a networking device, and what's a link. So now what we are going to do in our courses, we are going to use some terms throughout. So before we work with those terms, we first need to understand how those terms came into picture. Okay. Now, what I'm referring to is a very famous model known as OSI. So, how did it come into place? How did we start using OSI? So, it is said that the US government, right, their Department of Security agency was the first team who created the concept of computer networks, but then there are other countries who claim to do the same. So when they all had their own network components, they had their own ways of working with networks. Imagine if someone in India has to talk to someone in Canada or the United States through computer networks. How would they do that? They would they would use their own mechanisms, and that would not be so good in order to talk to the other person. Now, what I'm referring to here is I speak, let's say, Hindi, okay, and you speak another language, Italian. Now, when if I keep on speaking in Hindi and you keep on speaking in Italian, I'm not going to understand anything at all, right? You're not going to understand anything at all. So what we need to do is we need to standardize our way of communication. We need to find out what would be the common language that we can both use, that is English. So then we would start using English. Same went out for computer networking. India was using its own standards, US was using its own standards, China was using its own standards. So what did we need to do? We need to find a we had to find a common standard. So that common standard came through a company called ISO, International Standards Organization. So what did they do? They created a model called OSI. The reason they created it is because, like I said, a lot of countries had their own ways, they had their own ways of using computer networks, and then some of those ways would be very coherent with each other, whereas the others would not be so coherent. So in order to make sure that everyone in the world would be able to communicate with each other through computer networks easily, they created something known as OSI, Open Systems Interconnection. Now, what was the foundation of this OSI model? Layers. So they stated that in this model, everything would be based on layers. Now let's try to understand what are these layers. So for that, we'll take a very simple example, of our daily lives, even though we don't use this specific mechanism of communication anymore. So what I'm referring to, which mechanism am I referring to? That's postal mail. Well, nobody uses postal mail these days, but let's see how it works. So suppose I want to send a letter to my friend. How would that work? At a very basic level, what's going to happen is I'm going to write a letter, put it in an envelope, and drop it in a mailbox. Now, what's going to happen is after a few days, once I've written that letter, the receiver is going to get that letter and they will read it. That is all I know. So, as a sender of a letter, what I have to do, I have to write it, put it in an envelope, and drop it in a mailbox. After a few days, it is going to show up in the receiver's mailbox. They're going to pick it up and read it, right? That's a very high level, description of how you write and send a letter to someone. But what actually happens behind the scenes? So behind the scenes, what is going to happen? Once you have put that letter in a mailbox, it is going to be carried from the mailbox to a post office. By whom? By the postman. Then from the post office, what is going to be done? It is going to be delivered to the central post office, from where they are going to check who the actual receiver is, and then they are going to start delivering it. They are first going to deliver it to the post office, which is in the vicinity of the receiver's house, and then somebody is going to pick that letter from, well, the postman is going to pick the letter from that post office and deliver it to their mailbox. So this is what is actually happening behind the scenes or under the hood. As users, should we be concerned with how they are going to deliver the letter, what kind of mode of transport they're going to use? No, that is all hidden from us, right? All this, all this is hidden from us, okay? And the term that we use in order to describe this is abstraction, which means that this is happening, but we do not need to know about this. Take another example. You're driving a car, but do you actually know what is happening under the hood? Like when you turn on the ignition, you start driving, how is the fuel being injected? No, right? That is something that we don't need to know. We just need to know how to drive the car, and that's it. All of that is happening, but it is happening behind the scenes, under the hood. And is that, are those processes important? Definitely, because even for this example, if I, let's say, remove this layer, if I take this layer and I remove it, what is going to happen? Is the receiver going to receive the letter from the sender? No. The communication is going to come to a halt. So all this is hidden from us, but this is completely necessary. Getting my point, everyone? What abstraction is and the concept of layers? Any questions related to this? I hope this is simple, right? But what you need to understand from all this is the concept of layers. And the same concept is going to apply where? In the model that we are going to study next, which is OSI. So let me just clear the screen and go to the next slide. So yeah, OSI, what does it do? It is going to help standardize the communication, but through what? Through the concept of layers. So in the OSI model, you actually have 7 layers. Now, where are you as a user? Can anyone tell me? Where are you sitting?
Application.
Application layer.
Right? So we are on the
Application.
application layer. Are we actually concerned as end users? What is happening at the physical layer? What is happening at the data links layer? Which kind of switch they are using? What kind of fiber cable is it? Is it single mode? Is it multi-mode? No, we don't care about that. But if any of those layers are removed, or if any of those devices stop working, what's going to happen? Eventually, we are going to be affected because we are on the application layer. So what happens is when two people communicate with each other through the internet, both of them, okay, both of them have, you know, the 7 layers of OSI models on their ends. Now, what I'm referring to is, let me draw it for you actually. Whiteboard, yeah. Okay, so this is the sender. This is the receiver. Now, when we talk to each other, when the sender and receiver talk to each other, it looks like they're talking to each other like this, but that is not correct. How are they communicating with each other when it comes to computer networking? They're communicating to each other with each other like this. I'm not using my pen, so my drawing is really bad. So yeah, don't worry about it. So yeah, this is the sender who's going to send a message, and the receiver is eventually going to receive it. But it is not parallel. It is not going to be like this. Okay, I'm just going to remove this because it is going to be like this. Okay, and so both the sender as well as receiver have all these layers: application, presentation, session, transport, network, data links there, physical. On the receiver side as well, they are going to have physical, data links there, network, session, well, transport, and then session, and then presentation, and finally application. So what's going to happen at each and every layer? The message is going to stay the same, right? The message will stay the same. The only thing that would change is how these individual layers are going to understand that information or that data. So the two terms that we are going to use heavily starting tomorrow, because tomorrow we will start with our OSI model. So the first term is syntax and the other term is semantics. Syntax stands for the way we, understand something, or you can easily just you can say that language is syntax. For example, for all of us, the syntax that we are using in order to communicate with each other is English, right? Syntax can be different. You can use other languages to communicate with people as well, right? What is semantics? Semantics stands for meaning. Meaning stays the same. So whatever the sender sends to the receiver, eventually receiver is going to get the same thing. It's just that when it goes through, when the message passes through all these different layers, the syntax of the message or the information being sent is going to change. Make sense? So that is what syntax and semantics are. Okay. Syntax is just the method of communication, or which can be different. Semantics is the meaning, which will always be the same, right? So that is what OSI models is all about. Now, from tomorrow, what we are going to do is we are going to start with physical layer, okay, and then we'll work our way up to application layer. And what's going to happen is I'm going to discuss every layer in detail. So all the concepts within that layer are going to be discussed as well. For example, if you're on data links there, I'm going to mention or I'm going to start with the concept of hexadecimal addresses. And then so we will also try to work with MAC addresses within data links there. When we are on network there, I will start with the concept of IP addresses, and then we'll also try to understand the concepts related to subnetting. So that is how I'm going to approach, and that is how we should all approach the OSI model. We shouldn't just, memorize each layer and then move on to the next concept, because that's not how it works. If you want to understand how OSI actually works, you need to do a deep dive rather than just, understanding the concepts in breadth rather than depth. Got it? So, that is going to be all for today. It's our very first class, so I don't want to cover a lot of material. Now, when we meet tomorrow, we will start with OSI model. All right. So that's going to be all for today, everyone. Let's meet tomorrow and we'll work on the OSI model.
Sir,
Yes, Garvit.
sir, can you please also tell from tomorrow, can you please also side by side tell which topic from the CCNA syllabus we are covering
Right
so
now
that
we're
we can
not
make.
right. Yeah, right now we're not covering anything from CCNA because
No, no.
OSI model. Yeah, that's what I'm saying.
Okay.
OSI 802 project are not in CCNA. They are assuming
Okay.
that you already know that information. So once we
Yeah,
have
right.
covered this foundational information, right, or these foundational topics, then CCNA will start. And when we will start those topics, I'll have the official guide next to these topics, and we can mark which topics we have completed and which topic would be completed in the next class. Got it?
Yeah, yeah, right. So that we can make sure that every topic is covered and
Yep.
right, right. Okay, okay.
Sir,
That's the
how I
only question
download
I
the
have.
book?
Which book?
Actually, you just discussed some topic from there now, like what is network, topology, OSI model.
You don't need to download that book. That's a very old book. It talks about very, foundational concepts, and they are very old. So you don't need to actually download that book because, like I said, the concepts are old. So you can easily understand all of this via, through AI tools like ChatGPT or Gemini. I'll share all my own notes. They'll help you out. Don't worry. You don't need to go through that book. It's like I said, it's
Okay,
really old.
okay, thank you.
Yeah, no
So
worries.
tomorrow also it is the same time.
Yeah, same time. Yep.
Okay.
Yep. All right, then, everyone. See you tomorrow, and we'll talk about OSI model in our class then. Okay. Bye bye. See you.